Welcome back, everybody. Hopefully another exciting video here at Blue Glow Electronics. Just a few things. One, I've been getting some feedback on a few posts that my volume on my microphone sounds a little bit scratchy or tinny, so I tried a different setting on the camera this time. We'll see if this does any better. If not, then I'll look at it getting a different camera. This one has an external mic port, but I don't like where it's located because then you can't close the cover and turn it off. It's kind of a pain. So, at any rate, onward to the video. What we've got here is another Pilot 232. Pretty nice unit. Guy actually saw one of my first videos and contacted me and said, "Hey, there's a couple things I'd like to get done to mine." And I said, "Sure." So, first off, this thing has been restored before, so this is not a factory unit. As you can see, someone's put some gold-plated RCA jacks on here. It looks like they've replaced all the bolts on the transformers here with some gold-plated bolts. Somewhere along the way, someone's put in a F&T 50-50 microfarad capacitor here to replace the original factory one. And you can see they've kind of siliconed it in down here around underneath. Got an original made in Great Britain, Mullard 5AR4, otherwise known as the GZ34. And it's got 4, looks like GE output tubes. Thought I'd show you here. This is a typical invoice I put together once I finish something for someone, or I use the same form to send someone a quote, and I've done a little bit of redacting here with a magic marker to remove the prices and the names for this individual. But you can see back on January 1 I gave them a quote, and here was an estimate for servicing a Pilot 232, and this is what all they wanted done to it. They wanted some new banana plug jacks. So where this thing has speaker plug jacks, they want banana plug jacks put there, and they want them wired at 8 ohms. They wanted some 0.1 microfarad Sony caps put in it. I guess they're not happy with the Russian caps that are in this thing right now. So I placed an order, and my 4 Sony caps came in. So that's what's taken me a while. I've been waiting to get these things in. Got wanting to put in a 0.47 Russian paper and oil and a place or two inside of this thing, which we will do. Basically, he's wanting me to mimic what I did in my first restoration. Wanting an SL80 thermistor installed. The bottom of the chassis here has no rubber feet on it whatsoever, so it just kind of sits on the floor. Wants some new rubber feet installed on it. Wants a new cord strain relief and a new cord installed, and they sent me a cord to install, but I think this thing's a little heavy for this amplifier, so I'm going to go see what I can dig up. This one is certainly way too heavy. This thing's about 12 feet long. Let me show you the other end of it too. It's one of these cords that I absolutely hate. Here, the end of it, you can see, and I picked up some dog fur on the way with me here. You can tell I've got a few Australian Shepherds here in the house. But, yeah, I hate these ones that mount sideways at an angle like that. They're just kind of a pain. And then they want the bias checked on this thing, so I give a quote for replacing some bias resistors as needed. And I put in a couple hours labor here, and what I said would include would be a service, tube testing all the tubes. I'll do that. Replacing parts, biasing the amplifier, replacing the power cord, installing the thermistor. Anything else needing attention, we'll do a bench test THD on it and a frequency response. And I said, hey, the quote does not include any replacement of tubes if they need be, nor does it include return shipping, and I gave an estimate could vary by plus or minus 20%. So pretty standard invoice I do, and pretty standard what once someone pays, what I leave with them, so they know what they've had done to it. One other thing I'll show you real quick. And I've also had these printed up a couple years ago. They are service stickers basically, and on here it has the Blue Glow Electronics, my website, whether it's serviced or calibrated. I'll circle which one, the date, who did it, which is always me, and any notes about it or whatnot. And then I'll, like on this one, I'll end up sticking it on the inside here just to, so if it ever comes back in, I'll know when it was serviced and stand behind the warranty I put on these things. I typically put down here after "thank you for your business," I always add a note about 90-day warranty on everything I do. I hate to go much longer than that because tubes wear out, capacitors over time fail. You never know how somebody may be hooking this thing up, etc., etc. So enough rambling about what we're going to do, and let's dive in and get this thing going. Alright, you can see here, this I don't like at all. If you notice, this cord was so big and fat that on the strain relief they couldn't even use the little crimper side of it. It just basically crammed this thing down in here, and boy is it in there. But I don't like that because then you're wearing against the you know, as this cord wiggles, you're cutting against this metal into the cord itself. Over 20 years or so, you'll end up with a short there. We went and gathered up some parts. Got our SL80 thermistor here, CL80 we're going to put in. Got a nice 18 gauge power cord, just a standard IAC. I buy these in 20 packs, and they're not too bad expensive, but they're good quality, good silicone stuff. A lot less, that's too big and bulky for this amplifier in my opinion. And you know, just knowing the power output of these things, this is overkill. Anyway, this has got 18 gauge wire inside of it, and I thought I'd show you here. These are strain relief bushings, and it's what I use to push in here, and I use the Heiko pliers, which I left in the other room. But I thought I'd show you the difference between, you know, a couple packs of them here. If you'll notice, you know, they look pretty much the same from the front side, and you got to kind of match. I keep a couple different sizes. You got to kind of match the size of it up to the hole itself. But then, if you'll notice on this one, the little strain relief tab that pushes in, you'll notice it is flat. This is made for a 2-prong flat cord right here. If you'll notice on this one, the indentation that goes in, and you can see them compared side by side, it's concave and made for a round, and this is made for 18 gauge wire, so it's perfectly made for that right there. So if you go to order these things online, just search for the words strain relief bushing, and they will pop up, and you'll see a multitude of sizes. You need to figure out the size hole you need and whatnot, and I usually search for the ones made for 18 gauge wire, which is what I always order, and then it'll come back and you can pick the hole size from there. Anyway, we're going to dive in. Okay, so I got this old cord off here. I just used the Heiko strain relief pliers there, and wasn't sure whether I just wanted to throw it away or maybe hook it to the back of the SUV to use it to pull up stumps with in the yard. Up next, I just used the back side here, the big cutting part here of some Greenlee wire strippers, and basically chop the head off of this thing. I always mount these and get the strain relief mounted before I strip the wires. Otherwise, you're dealing with you know, running stripped wires down through here. Okay, doesn't that look much better, much more professional, etc. Just the way to go. If I'd have used this cord, it's really big and fat as well, I'd ended up in the same place where I wouldn't have been able to use the grommet properly. So this is the right setup here, and there's no way to pull that thing out. It's locked in there very good on both sides, just the way it's supposed to be, and that crimp is made for this size wire, so it's all done properly. Alright, this part of this strip where I actually remove the outer sheathing here, you can see. I usually do that with an X-Acto knife here. I get a really sharp blade on an X-Acto knife, and I just start a slit on one side and I work my way around. The goal in that is to not cut any of these wires here as you go around the three. Ultimately there's a cloth piece in the middle that I will snip off. But the goal is not to nick any of those wires, and if you try doing it with a pair of cutters or something, you'll inevitably nick one of these wires. But once you get it around there and you kind of bend it around as you go, You can pull that whole black piece off just like this, and we can toss it in the garbage over there. And we're now ready to strip these off at the right lengths, cut them to length, cut this cord piece off here and strip it. And we've got it all soldered in. The white went to the fuse connector here, the black over to a connector that feeds over into this plug and back in, and then the green goes over here to the chassis of this capacitor here, which is at ground. Anyway, we're going to keep going through this thing, see what we dig up. Up next, I'm going to replace these speaker terminal outputs here with some banana jacks, and the way those are typically done is you pop out these the original little metal pieces that are in this wafer board here, and you leave the wafer board, and you'll use you'll go through this spot for the black and through this spot down here on the other end for the red, and then you tie whichever wire you want to, like in this case 8 ohms. If you'll notice here on the other side, let me get it in the light here a little bit. The common side of this, the negative side, actually goes via this wire down to the tube socket to ground, basically to the chassis ground. Then you got a wire here, a couple wires, green wires coming off of the 8 ohm piece, and you got one wire coming off the 16 ohm. I'm going to cut the 16 ohm wire taps and put a little bit of heat shrink tubing around the end of them. Just kind of leave them laying free here so that they will they won't short out or anything. And then what you'll end up with there is on the 8 ohm, I'll end up moving it over to this side. One of these comes from the transformer, and it feeds the output. This little green one here that you can see my fingers on, it feeds back over here. If you'll notice, it comes back to this point. That's the negative feedback loop coming off the output. You'll see the same thing feeding off the 8 ohm tap here, so we'll have to make sure we put that back onto the 8 ohm tap as well. As you can see, I've cut the ground wire loose here and here. We're going to reuse those. And as you can see, I've cut the 16 ohm tap off, and I put some blue, just some blue heat shrink tubing. I actually just pressed it down over the wire. Once it was on there, then I cut it off a few inches, a few millimeters up from that, and got it hot and heat shrinked it on there. So no worries now about those things shorting out. Okay, as you can see now, I have popped out these little things. All you do is run the screws all the way out. Let me give you a little demo, and I'm not going to actually do it, but you run the screw all the way out like this till you got enough for him to grab with the pliers. Then you get your needle nose pliers of some sorts. You grab down in here and you start wiggling very gently, very slowly, and these things will pop out. And so what you end up with is the fiber board with kind of 2 square holes in it here. And then what you're going to end up doing is, as you can see here, this is my personal pilot amp. You're going to end up mounting 2 of these, and you can see there's good mounting on the other side. I do leave the center one in here, even though it's not hooked up at all. And well, I need to do mine like this. I bought this one and haven't done any restoration work on it, so it's kind of the way it came. Was, if you notice, the original capacitor and whatnot here. At some point I got to get around to doing this one, but someone had done some work on it at some point, and put these jacks on it. But while I got it sitting here, I'm going to go ahead and put some heat shrink tubing on this 16 ohm taps. Alright, got some blue heat shrinking on my 16 ohm taps as well. It's funny, they always joke about the painter's house is always the house that needs painting. I have got so many amplifiers and stereo units. I was in the other room the other day counting. I had almost 20 Marantz units that are mine, and we were wanting to put one in my son's bedroom, and I was trying to find one that was in fully working condition, and I couldn't. So we ended up finding one and put it together. Here, I'll throw a picture up for you and let you see what it ended up looking like. But you know, it took me and him a couple hours. We did pretty much a relamp job on it, recap, deoxed everything, and we got that thing running in his bedroom. But you know, it's like a man with 20 Marantz units and none of them work. That's the story of a you know, electrical engineer's life. Well, these are the speaker binding posts I'm going to use, and I noticed as I was taking them out of the bag, I'm down to my last, I've got one more set after this. So what did I do? I jumped on eBay, and I'm going to buy another, I'm going to buy 24 of them, 2 12-packs, so should get me by for a little bit longer. Okay, as you can see, I've got the black wire that goes to the common, as well as I need to ground it here with that little bitty wire that went down. And I've got the green 8 ohm coming out of the transformer, and I've got the negative feedback loop. So those will be the 3 that I connect up. Similarly, I pulled the wires back on this side too, the black and the 2 greens, and we're going to get these things in here and get them mounted. Okay, one thing I found is these things come through. If you're not careful here, you end up too far over to the left. You get mighty close to this pin socket, tube pin connection right here. So what I ended up doing was I ground a flat spot on one side of this thing, nice and neat, which gives me a little more room to mount this thing all the way over here up against this socket here, versus it being pushed way over here, which gives me a whole lot more clearance here on the, as you can see down in there, good little gap now between that pin tube connection and the end of this terminal lug. And we're there. All these are mounted up good and tight, nice on here, good and solid. You can see the 4 lugs that we pulled out. And you know, just give you an example. I know this in the video, probably 3 shots at 20 seconds a piece, but I literally have an hour at this point in putting these things on here. It's a good bit of work. You know, I had to go down here and make sure I rerouted stuff, made sure pins were out of the way, played around with a couple different lengths on these pins. I had some shorter ones here, but they didn't help out much either. Had to move some cables out of the way here that were in the way of these things, and I still have not even soldered these things up yet. So you know, sometimes what you see that may take 30 or 40 seconds, maybe a minute on this video, might be me messing around for a half an hour or an hour in between. So don't look at all this stuff and say, wow, that's so simple, I could do that in 5 minutes or less. Spent a good little bit of time fitting these things and getting them just right, and shaving, like I said, off the sides of these things so they fit in there quite well. But you know, at the end of the day, they look really nice on the back of this amplifier, and well, you know, you can take just plain old banana jacks then for your speaker wires, which I love to use here. These are soft silicone, man. They are super easy to work with. 4mm banana plug jacks. You know, they just plug right in, and I love to put banana jacks on the end of all my speaker wires, if that makes sense. Alright, sorry you can hear my furnace roaring in the background. We've quite a bit of snow here right now, and the fuel, I've got a circulating hot water heating system in my house that runs off of fuel oil, and it likes to crank up regularly in the room right next to me. At any rate, I was going to show you a tip. So I've stripped the wires here that I've got to connect. And these old transformer wires, when you strip them, you'll notice they're just kind of gummy and cruddy even still after you strip them down a bit. And what I'll do is I'll come on, I'll put a little bit of liquid solder flux on these things. So it'll help clean them up a little bit, and puts you know, helps a lot when it comes to soldering these things. This little thing just has a little brush on it like a fingernail file, and I'll just brush a little bit on the end of each of these wires. Okay, while I was at it here, just thinking about it, I went ahead and did the EL80. If you notice, I connected one end really firmly to the tab here of the fuse holder, kind of laid this thing flat, and then the other side I soldered to the wire here that would feed over to the other power junction, and then put a little bit of heat shrink tubing around it. And that thing's in there good. Plenty of clearance here between it and the bottom, and should work out great. Okay. We've done enough to this amp at this point that I wanted to make sure everything was working well. Keep in mind, this amp was working when it came in. He wanted some things changed about it. So I just want to make sure all the soldering work I did here around the wires and moving tube pins out of the way and rerouting resistors and whatnot, similarly over here. And I want to make sure as I wiggle these things that there's no issues there, but so far so good. The CL80 over here heating up and working just the way it should. So new power cord, CL80, new output jacks thus far, and things sounding good. Yeah, it's a little muddy sounding. I can see why the guy wanted to replace these caps. So we're going to see if we can brighten it up a little bit. Okay, we got the Sony caps here. Got I was just checking to make sure I got the right size Teflon tubing here for the leads, and we do. So we're going to get busy now putting these things in place here, cleaning up a little bit of this work in here as well along the way. Ugh is about the only word I can think of. How somebody had wired that thing. Yeah, if you can see here. Now we've got the new Sony cap in here with the Teflon coating going all the way down to the lead on that one, and coming off the other side here going all the way down to the lead. So nice in place, held neat, and will last a long time like that. So we'll move on to this one. And this is the other thing I don't get. They mixed and matched types of the Russian paper and oils here. And this is a push-pull amplifier. So if you're going to do anything, you should have put like these two types over here and these two over here, but at any rate, not sure why, but that's the way it was done before. Okay, second one's in here, nice and neat. These things are starting to turn out pretty good. I'm happy with how they're going. Okay, in case you didn't watch the previous video where I installed these Sony caps or any resistor or whatever, I always put the Teflon tubing onto the wire, okay? Then I pull it back just about that much. You can see right here, it's about 1/4 of an inch. And then I'll come along here and right at the end of the lead, I'll cut that off, and then I slide it on there, and it gives me the perfect length. It's the easiest way I've found to do this. If you try eyeballing it, laying it over here, etc., etc., 9 times out of 10 I come up wrong. This way I'll get it right just about every time. And as you can see, 1, 2, 3, 4, all in place, really good and sturdy. Nice Teflon wiring or wire cover on each one, looking really good. Looking good. Sounding good. I'm liking it. Alright. Sounding good. Still want to check out the bias on this thing, and turn that down a little bit. Still want to check out the bias on it and whatnot. Really, at this point, all I've done is replace these two here. He wanted to do it just like I'd done the other one with the .047 Russian paper and oils, the Sony caps. Check out the bias next on this thing and see how it's running. Okay, we're in here testing the 4 output tubes. I want to make sure they're matched before I go biasing this thing, and you'll see the 6BQ5 settings here, and a minimum value of 50. We've already set all the settings at this point, and we do our line adjust here, and it looks dead in the center, and then we go to 3, and it looks like we're sitting at 92 on this one, so it's a really good tube, and hopefully it'll match up well with the others. And the second one test out at 101 here. We're going to have to, I mean, they're both great tubes, they're just not extremely well matched. And tube number 3, push the mutual conductivity, about 102, so not bad. That one would match up well with the other one. Alright, and this last one tested about 92 as well. So here's the scenario I've got. This is quite an interesting scenario. So I've got two that test at 92 and two that test, one basically test at 102. They would make nice matched pairs and be symmetrical on this side and symmetrical on this side. What you wouldn't want to do is mix a 92 and 102, then you kind of get an unsymmetrical waveform which causes distortion. The issue you will have is that this channel will be louder than this channel. Okay, you can see I've lifted one end of the resistor here, the cathode bias resistor, and 125, 126 ohms. These are 120 ohm resistors. That's well within spec there. And I thought about replacing these with some 150 ohm resistors. What that does is it lowers the current flowing through the from the plate to the cathode and makes the tube life a lot longer. However, you end up with lower volume. So I might try it out and see what we think. If the volume stays high enough, we'll put the 150 ohm. I've done a few others with the 150 ohm, and they've turned out quite well. Alright, so I've got the 250 ohm resistors in there. And if you notice, I'm measuring the voltage across this resistor. I've basically gone over here to the cathode supply, which is the same point as this end. And I'm measuring to ground and getting 13.1 volts basically. Let me show you what that means. So if you enter in the 13.01 divided by 150 ohm resistor here, remember I equals V over R, you get 86.7 milliamps flowing through those tubes. I can tell you right now, when I first measured the original 120s that were in it, I measured across it, and I had a little over 102 milliamps flowing through those tubes. Let's pull up the RCA manual and see what it says. Okay, if we get out the old RCA tube manual, see we're looking at the 6BQ5. Come over here to a push-pull Class AB amplifier, and you get here and start looking at maximum signal plate current, and you end up with somewhere between 75 and 92. And we're running at 86.7, so we're in a great spot right there. Should have good tube life. The 102 that this thing was biased at before would have been really hot. And if you notice in here, this thing actually recommends a cathode bias resistor of around 130 ohms, which would probably put you a little closer here to the 92. But I'm happy with where this thing's at. You might could squeeze out just a teeny bit, a little more volume out of it if you wanted to, run it hot, but at the same time you start getting some distortion and you shorten the tube life greatly. So pretty happy with that. You can see this manual and it's seen better days, but if you ever go pick one of these up, just dig around, find you an old one if you can. Somebody's reproducing these and they're making new copies of them, but you can tell when you get to the pages that they're the lettering's not very crisp, and RC30 is the latest edition of this, so grab you one of these if you can. This one's from probably, I don't know, late 60s or so. Okay, we've mounted some rubber feet on here. I use these, proudly made in the USA. If you're wondering what size, they are 7/8 inch in width, so from one side to the other, and they are 3/8 inches high, and they've got these nice little metal curls on the inside of them. So when you tighten down on them, they don't kind of spread out or whatnot. Really good rubber feet. Pick those up off of eBay as well, and you can see I just used a standard screw and a nut with a lock washer on it, and these things are on there nice and neat. We're going to head back over to the other side and see how this thing's sounding. Alright, this thing's sounding good. Got the 150 ohm resistors in here for the bias, cathode bias resistors. Let's get it hooked up and do a little testing on the outputs. Okay, here's what we've got going on right now. I'm basically coming out of the output here on the 8903 audio analyzer. Got a 1 kilohertz tone coming out right now. And I've got a 0.3 volt signal, so yeah, amplitude 0.3 volt, which is close to line level. That's about what you'd be getting out of an iPhone. 0.5 is line level, or 0.4 to 0.5. So that's about what you'd get out of an iPhone right there. If you'll notice over here, the sine wave that's coming out, nice and clean on either sides. No distortion. But check this out. I'm going to flip from the left channel to the right channel here, and we're at 0.82 volts there. Now we're at 0.82883, so virtually no change whatsoever in output. So even though these tubes weren't matched perfectly left and right channel, they've turned out fine. Maybe if you drove it a little harder you would see a little more, but check this out. Distortion wise here, this is the left channel running at 0.09% distortion right now. And if I go to the right channel, just a test, like 0.14% distortion. I mean, that is extremely low. Okay, you notice we're running down here in the 0.9% distortion. I'm going to jack it all the way up to full line level. Amplitude 0.5 volts. And you can see over here, I've had to adjust the scope, it went off scale, but it's still nice and clean. When I go left channel, right channel, really 1.37, 1.30. I mean, those things are pretty darn close. And even here, distortion, 0.11% at full drive, 0.24. I mean, that's so low. Similarly here, there's no harmonics really to speak of on either channel here. They're just both nothing there beyond the original signal. So pretty darn happy with how this thing's turning out. Okay. The 8903B, great unit, but you know, every unit has its limitations. This one, it only puts out a sine wave and does all its measurements based off of that, and so basically turn it off. I'm feeding now into out of a B&K Precision here, and I'm at the 1 kilohertz range, so basically right here, if I can adjust it, I mean I'm at a kilohertz right there. And a sine wave, and as you can see here, getting a beautiful little sine wave out on the output. But check this out. Even on the output here, keeping a nice trapezoid on a trapezoid signal. I'll switch over to the little bit of slew on the curve here, square wave, but there's no overshoot, no ringing. I'm as happy as could be with that. That's why the distortion is so low on this thing. Couldn't be any happier with this thing. And finally, I turned the 8903 on, put it in automatic mode, and let me show you what I ran over here. Okay, I used some of the Peep Millet software, and I ran a frequency response. Started at 20 hertz and ran all the way up to 30,000 hertz with 3 points per decade. Check this thing out. You know, up to about here, it looks like around 20, 30, 40 hertz. This thing's down about 1 dB below 30 hertz. Then it takes off 40 hertz. Then it takes off, and this thing is flat. And you can see I've ran 2 lines here. I don't know if you can tell. I've ran this thing twice. I ran it first with the yellow line, then I ran it with the other channel, which is the blue line. And these things are almost perfectly superimposed over each other. Just the slightest little bit of difference down here. But I mean, all the way up here till you got, right up around the 8, 9, 10K. Started dipping a little bitty bit, but even all the way out here at 20K, you're still down only, 1 dB. So I think that's a dang good flat signal. Both sides match very well. Extremely happy with how this thing's turned out. I know the customer should be as well. Okay, we got the top back on it, screws mounted on it. Let's get it flipped over real quick. Okay, just a few closing thoughts on this amplifier. One, I always like to return all the parts back to the original owner if I can. You know, the way it shows them what I've done, and two, hey, they may need these parts for another project one day. Second thing is, if you remember on the outputs here, we had like 92 and 92 and 101 and 102 basically it was. So a pretty good match parametrically on this side and a pretty good match parametrically on that side. But you know, and I thought, well, it could cause a slight imbalance in the volume between the two channels. Well, you saw once we got the thing hooked up and we're measuring with a consistent input, we were getting a consistent output, even when driving the thing all the way up at 0.5 volts, which is full line level. So don't get all wrapped up in the tech specs of maybe tube testing values. A lot of tube testers test you know, mutual transconductance and not true GM and things of that nature. So you know, the ear tells you more than anything, because ultimately your oscilloscope's not what's listening to your music. Your ears are. So I'm very happy with how this thing turned out, and I hope you guys were too. Stay tuned and we'll keep bringing them. Thanks everybody.
You're gonna top yourself.